And I have a great pleasure to give a floor to the next speaker. He was already introduced, Mario Estevez. He got his PhD in food science in 2005. His research is concerned not only with food quality, but also in relation to human health. He is publishing a lot of papers. He published more than 100 of those. And his specific interest is related to oxidation and the process of protein oxidation, something which Mario was one of the first. And for the last few years, he published quite a few reviews on this subject. And when we're talking about meat quality, the protein oxidation, something which actually came very recently, and we started to realize that protein oxidation in many cases is even more important than lipid oxidation, especially when we're talking about drip loss, when we're talking about other parameters of meat quality. Therefore, I think his presentation, which is entitled Meat Conservation and Further Processing, it's actually the third part of the meat presentation, because first was on muscle biology, second, the defects which actually developed due to different problems in processing and growing birds, and it was shown that oxidative stress in many cases is at the molecular level is imposed, and Mario, I think, will be delivering this lecture, and we are looking forward for your lecture. Please.
Thank you, Peter. So once again, it is a pleasure to be here also as a speaker. So basically, as Peter said, I will end up this session talking about meat preservation and further processing. So this is basically the outline of my presentation. I will start with an introduction in which I will talk about the connection between animal nutrition and meat quality. Then I will present the most relevant hazards that we may face during meat storage and meat processing. Then I will try to do something very practical, which is to try to identify these hazards whenever we face these hazards in a real situation. And naturally, because we try to implement this knowledge into this real situation, we'll try to give advices to avoid these hazards when they appear and they become a real problem, and also to find solutions whenever it is possible. And I will conclude my presentation with some final remarks. So it's basically the theme of this session, which in a way illustrates in a very interesting way the connection between animal nutrition and human nutrition, in a way that feed quality has actually an impact on meat quality. So in a way, the theme of this session reflects, or in a way propose, that animal nutritionists would be also responsible for the quality of the final meat product, which is something to keep in mind, something very interesting, because in fact, feed quality, together with the genetics and animal handling, will actually have an influence on meat quality. Meat quality has been said before, but it's basically defined by the sensory properties, healthy properties, and also the safety, and some ethical issues that they have been mentioned before. And for instance, the feed composition, in terms of fatty acid composition, would actually have a direct influence on the sensory properties of meat in terms of the onset of rancidity and also the flavor. Also, once again, the feed composition in terms of fatty acid composition and also the presence, the supplementation with antioxidants will also have an influence. If we supplement the feed with antioxidants, that will lead to a more stable and more healthy meat lipids. Also, if we apply antibiotic-free feeds or phytogenics, that would also contribute to have a more safer meat in terms of meat free from some potentially dangerous chemical compounds, residues in the meat. And finally, the natural or extensive feeding based on natural resources, fruits and vegetables, would also contribute to the image of environmentally friendly production system that is actually in mind of some consumers with very specific ethical issues that we can actually address with this kind of natural and extensive feeding. So as you can see, the theme of this session relating the role of animal nutritionists on meat quality is actually very appropriate because, as I said at the beginning of the presentation of this session, some decisions that we make at the farm will actually have an influence on meat quality. So this is something to keep in mind because in a way when you, as animal nutritionist, you design animal feeds, to some extent you are also designing the meat, the quality of the meat that will be delivered to the final consumer. So now let me move to the next point of the presentation to talk about the hazards that we may face during storage and further processing of meat. Meats that we get from a slaughter after post-mortem changes, the transformation of muscle into meat. This meat is actually very unstable from a microbiological point of view, as you know, very perishable, which means that we need to preserve the meat, usually using low temperatures. Refrigeration, if we want to preserve the meat for several days, or freezing, if we need to preserve the meat for several weeks or months. The meat is eventually delivered to the consumer, and before, naturally, because we are talking of fresh, raw meat, we need to apply some kind of cooking procedure, and the temperature, time, and the type of heat transfer that we apply to the meat will have consequences on the quality and safety of the meat. The other possibility is that we process the meat. So this means that basically we will apply different technologies to transform the meat into different types of meat products. We can do that directly from the meat coming from a slaughter or after a storage. It is very typical in the meat industry to freeze the meat for a certain period of time, several weeks, months, no more than 5 months, and then defrost and process the meat to produce different types of meat products. All the technologies that you may think of, size reduction, mincing, high temperatures, irradiation, salting, curing, all of them will have consequences on the quality and the safety of meat. And naturally, processed meat will be delivered to the final consumer. During all these routes and pathways, meat will be exposed to 2 different types of hazards. Chemical hazards, basically oxidation, and biological hazards, microorganisms. And I will elaborate a little bit more about these 2, starting with the oxidation. As you know, oxidation is a chemical reaction typically initiated by free radicals, even though some physical factors, particularly in meat, such as light and irradiation, they can also initiate this reaction. And let me discriminate here between lipid and protein oxidation, because even though the origin or the initiation is usually governed or is usually initiated by these free radicals, the truth is that the underlying mechanisms, the pathways, the oxidation products, and the consequences for the meat and for the consumer are fairly different, as you will see. Lipid oxidation involves the degradation of unsaturated fatty acids and in the presence of molecular oxygen. It is a ubiquitous reaction. It will be present from farm to fork. This means that, of course, it will be present in the living animal, what we call oxidative stress, when this oxidation is actually affecting biomolecules, molecules of biological significance, and will take place during the whole production chain, storage, processing, and also in the final consumer. We are also susceptible to oxidative stress. But it will be particularly stimulated, promoted by some processing techniques, in particular by high temperatures. And this lipid oxidation is something to keep in mind because it's the main cause of consumer rejection of processed muscle foods. Basically because of their rancidity. The onset of rancidity is probably the most striking and short-term effect of lipid oxidation in processed muscle foods. Then it is also supposed to be responsible for the discoloration of fresh meat from bright red to kind of brown. We'll see some picture in a while. There will be also a loss of nutritional value because basically when an essential fatty acid is oxidized, is lost. This oxidation is irreversible. And actually we know that some muscle foods and also some other foods are very good sources of essential fatty acids. But when these fatty acids are oxidized, then they are lost, and there is an obvious loss of nutritional value. And finally, this is not the least important, actually, but it's usually referred at the final when we list different consequences of lipid oxidation. Some products from lipid oxidation are potentially toxic to humans. This is actually, well, we say potentially, but in fact, lipid oxidation products, they have been shown to be involved in the pathogenesis of different disorders in humans. Some cardiovascular diseases and different types of cancer and so on. What about protein oxidation? Protein oxidation involves not only the degradation of particular amino acids, but also sometimes the aggregation of proteins. Proteins, when they are oxidized, sometimes they aggregate to each other. As well as lipid oxidation, it will happen certainly in the living animal and also during processing and storage of meats, also in human beings, which actually is a hot topic in medicine because of the relationship between protein oxidation in human beings and different very serious health disorders, in addition to aging. In muscle foods, it is also stimulated by high temperatures. And compared to lipid oxidation, we can say that it's a silent but very serious threat. I say silent because compared to lipid oxidation, there is no such striking, remarkable modification of the sensory properties, such as the rancidity that we mentioned before. So in a way, we can have protein oxidation in our meats or meat products, and it actually can pass like unnoticed by the consumer or by the retailer or by the meat producer. But actually, I say that it's a serious threat because it has some consequences, including some texture problems, in particular strengthening of the muscle tissue. There is also a loss of nutritional value, basically, because the loss of essential amino acids, and actually we know that meat, as well as some other foods coming from animals, they are very good sources of high quality protein. Some of the essential amino acids, sulfur-containing amino acids, tryptophan, lysine, all of them are very sensitive to oxidation. And then we also have some digestibility problems. I'm talking about human beings, of course, because some oxidized proteins, they will be more difficult to digest. They may not be recognized by our digestive enzymes, and then they can actually travel through the gut without being digested, would actually, in a way, add more impairment to the loss of the nutritional value that involves the oxidative loss of the amino acids, of the essential amino acids. And finally, as well as lipid oxidation, this is quite rocketing topic, but still we know that certain protein oxidation products, they are also potentially toxic, mutagenic, and they can actually be involved in the onset of different health disorders in humans. Now let me move, I will describe very briefly the biological hazards. In here we need to discriminate also between spoilage, microorganisms, and pathogens. The spoilage are usually coming from carcasses and then machinery. These are some of the species and some of the microorganisms that we may we have to meet during the meat processing and storage. They are very typical to spoil meat during storage. And compared to lipid oxidation, we said that lipid oxidation is a main limiting factor for the quality of processed muscle foods. In this particular case, this spoilage bacteria will be the main limiting factor of shelf life in meats under refrigeration, so basically fresh meats. Basically because these bacteria are able to spoil the meat. And this is a real spoilage. The sensory properties are spoiled, the appearance, the flavor, the color, everything. What about the pathogens? Pathogens, they are also coming from the carcasses, from the animals, but also they are very typically coming from the manipulation, from basically humans manipulating the meat during processing or storage or delivery. These are some of the most typical and most dangerous bacteria pathogens that we may find in meat. As you all know, they are responsible for very serious foodborne diseases. Luckily, not so often anymore, but still they may occur, and sometimes with very severe consequences for human health. And as well as protein oxidation, they may be there in the meat, but because there is no spoilage of the sensory properties, sometimes they pass unnoticed, and then we see the consequences when we eat the meat of the muscle food, and then we have the symptoms of a particular disease, of a foodborne disease. We have a variety of diseases, gastrointestinal infections, botulism, meningitis in the case of Listeria monocytogenes, and so on. Now that we know which are the main hazards, now let me move to the following topic to see how can we identify these hazards in a real situation and how to deal with these problems, trying to propose some strategies, some solutions. And I will start with the storage under refrigeration. Whenever we keep meat under refrigeration, the temperature should be as low as possible. Typically between 7 and 0, but there is something which is quite innovative, particularly in meat, not that much in seafood and fish, because it has been used for some time now, but this super chilling involves that we keep the meat below 0, but the meat remains unfrozen. This is very interesting because there is no change in the state of water, so there is no real freezing, but the meat will remain in a way without spoilage for a longer time, of course. This is particularly interesting when you are interested in trading or selling the meat to a distant country without using freezing, because freezing involves a loss of quality always. But even if we are using this super chilling, eventually we'll have some biological and chemical hazards. I will describe the symptoms that in a way describe or reflect that something is going wrong with the meat. I will try to identify the potential, the most likely cause, the reason, and then the solution. Probably you have seen before this slime together with off flavor and the discoloration. I believe that there must be some kind of problem with the pictures because the quality, there is some missing pictures also at the beginning, now here. So something wrong with the pictures. But anyway, whenever we have a slime of flavor and discoloration, it is very likely that we have contamination, the growth of some particular bacteria, in particular Pseudomonas, which is very typical, the spoilage of fresh meat by this bacteria. And basically what we need to do is good hygiene practices, packaging, very typically vacuum packaging, and the usage of antimicrobials, those that are allowed to be used in fresh meat, of course. And then when we pack meat in the vacuum, we may also find slime together with sourness. In this particular case, the reason is probably the growth of lactic bacteria. The solutions are basically the same. And then let's move to something that actually doesn't have a microbiological origin. It's a chemical problem, which is the discoloration of the lean. As I said before, from red bright to some kind of like brownish color. This responds to the oxidation of the myoglobin, which is the main responsible of the red color of meats. And because it's a chemical problem, and related to oxidation, it needs to be treated with antioxidants. And I will elaborate a little bit more because knowing that we are in a conference in which animal nutrition is one hot topic, I will elaborate a little bit more about these antioxidant solutions because in fact we can control oxidation in meat not only by adding antioxidants directly to the meat and muscle food through formulation, which is something that we can do, of course, but also through dietary means. So basically supplementing these antioxidants in the diet of the animals, and that will definitely will have also a positive effect on the oxidative stability of the meat. Will protect the myoglobin from oxidation and also the bone. Whenever we have bone exposed to the air, that can also suffer this discoloration. And this is basically the result of the oxidation of another pigment, which is present, as you know, in blood and also in the bone marrow, which is the hemoglobin. And basically the strategies are pretty similar. And then we have a problem with the texture. This is very typical when we are aging meat, particularly beef, in a high oxygen atmosphere. This high oxygen atmosphere is very typical for red meat, red muscles, because it is very good to preserve the right red color of fresh meat for a longer time. This is actually mentioned here. This high oxygen modified atmosphere packaging is actually good for keeping this oxymyoglobin, which is responsible for the red, bright red color of fresh meat, but on the other hand, will promote protein oxidation. And protein oxidation is, in fact, the responsible for this impaired tenderization that will take place in meat, in beef in particular, aged in this type of packaging. So it is better to age beef for several weeks, and then after that, when the meat is truly tender, we can we can pack the meat in high oxygen or basically in the vacuum and then sell the meat. Because like this, we can avoid this problem. But another possibility, if we have to use this high oxygen packaging atmosphere, which is, as I said, very typical nowadays for marketing different types of beef muscles, then we may combine this packaging with antioxidants. Once again, it is proven that both dietary antioxidants and also antioxidants that we add directly in the meat will protect proteins against this oxidative damage. Now, what about freezing? When we freeze meat, basically we can forget about microorganisms because they will not grow. But it doesn't mean that we forget about microorganisms because when we defrost meat, the microorganisms will remain there. So by freezing, we are not killing bacteria. All right. So they will remain there, but during freezing, the length of freezing is not limited by the growth of bacteria because they will be completely controlled. But then we have chemical hazards during freezing. Once again, the temperature should be as low as possible, but for obvious reasons, we cannot use -80, like when we store samples for analysis in the laboratory. So at the industrial level, usually it's -18, -20, and we shouldn't prolong this storage for more than 5 months because of these chemical hazards. Which are the symptoms? The most typical is the rancidity. The rancidity will appear after we defrost the meat. So not during freezing, will not appear as such, because basically the meat is frozen, but after defrosting, this rancidity will increase very fast, and actually after processing, the rancidity will increase also even faster. So this is actually a very limiting factor because the quality of the final product will be very low if we keep meat for a longer time at these freezing temperatures. Another possibility is to have protein oxidation. Protein oxidation would be responsible for the severe drip that we may observe in meat after defrosting. And we also have protein oxidation responsible for the technological problems that we may face when we want to produce different meat products from frozen material. Sometimes we keep the meat for a long time, and then we try to produce sausages, or we try to produce cooked ham, or even dry-cured hams, and then we realize that we have some technological problems. The proteins are oxidized, and they are not able to form emulsions, they are not able to form gels, and then we have this fail at processing. Which are the solutions? Basically, try to inhibit oxidative reactions. Usually, meat is frozen, vacuum packed. This is very, very typical. And in addition to that, we can also use antioxidants. And what about processing and cooking? Let's start with the chemical hazards. So basically, oxidation, as I said before, and rancidity in this particular case is the most limiting factor of the quality of processed and cooked meat products. And what about the strategies? I mentioned before, antioxidants. Avoid unsaturated fats. Unsaturated fats may be good from a nutritional point of view and healthy point of view because unsaturated fatty acids are supposed to be involved in lowering the high-density lipoproteins, so they are good for lowering or for keeping good cholesterol levels and so on. But unsaturated fatty acids are very susceptible to oxidation. They are very easily oxidized. And for processing, that is not very good because their rancidity will appear very soon as long as we manipulate the meats. And this is actually a problem for poultry because poultry is naturally unsaturated meat. Or the lipids from poultry is naturally unsaturated, more unsaturated than pork, and pork is more unsaturated than beef, than ruminants, as we all know. And then we can actually optimize this process. This is also very typical. We can optimize so that we can make a full cooking or full processing, trying to minimize the lipid oxidation. There is a particular cooking method that I don't know if any of you know this sauce vide. It involves vacuum package. So first we pack the meat in the vacuum, and then it is immersed in water and cooked for a long time using low temperature, so that the meat is very tender and lipid oxidation is limited. The flavor is not the same as putting the meat in the grill, that I can tell, but that's another option. And then, of course, we have antioxidants that I will mention also a little bit later in my presentation. And then we have texture problems, softening, which is very typical when we are trying to decrease the concentration of sodium chloride in meat products. This is very typical when we are trying to, which is actually a global strategy in the meat industry and some other food industries because of the problem of sodium chloride and hypertense consumers. So basically, when we decrease the sodium chloride too much, then we can have some texture problems because of the very intense proteolysis. And then if we have the opposite, a strengthening, that is always due to protein oxidation. All right, and then we need antioxidants. And finally, we may have some toxicity hazards as a result of the formation of toxic compounds during processing and more particularly during cooking, in particular when the cooking is very severe. And the barbecue is one very, very good example of a cooking procedure that, depending on how we deal with it, we can actually promote the formation of some toxic compounds that we all know, like the benzopyrenes, nitrosamines, and very specifically these polycyclic aromatic hydrocarbons. Because of the exposure, the direct exposure of the meat to the fire, or the burning fat, or the smoke that also contains some potentially toxic compounds. What about the biological hazards in processed meat? In most cases, we don't have problems with the spoilage because usually cooking and processing involves a reduction of the microorganisms. We are killing microorganisms by high temperatures, but still we can have some problems like bone taint, this deep meat spoilage, anaerobic bacteria, also the excess of mold and yeast, particularly in dry cured products. But these problems are, in a way, easy to handle because just take into consideration that we need to control in a very precise way the humidity, the temperature during processing, and sometimes using starters. But it is more or less easy to handle. The problems with processed meats regarding the biological hazards is definitely the pathogens. They may be present and remain present in the meat even after processing and after cooking because of two reasons. I'm listing here some of the most relevant bacteria responsible for foodborne diseases in humans. We have basically two options. When these pathogens are present in the meat, it's because the meat has been undercooked. This is one option, and basically the bacteria survived. And then it will remain growing after this cooking, when it's kept in under refrigeration. This is very typical in ready-to-eat meals that are pre-cooked, then they are kept for a certain period of time under refrigeration, and then there is reheated. But this reheated, which is usually performed in a microwave, is not enough to kill this bacteria. Right? And then the other possibility is the manipulation. So we kill the bacteria if the meat is fully cooked, so it's no problem. But then if somebody manipulates the meat, there can be a recontamination, and then this bacteria can actually grow under refrigeration. This is very typical for Listeria. Listeria, which is actually very dangerous because of that reason. It's very easy to kill this bacteria with high temperatures, but then the problem is that if it survives because the meat is undercooked, or basically because somebody manipulated the meat after that and contaminated the meat, then this bacteria is able to grow even at low temperatures, at very low temperatures. It's psychotrophic bacteria, so it's able to grow at very low temperatures. And as you can see, and now that we are in a conference talking about animal nutrition, let me give very brief comment on the different strategies that we can apply through dietary means, so basically through animal nutrition, to protect meat against oxidation, against lipid and protein oxidation during storage and processing. Something that I mentioned before is controlling the fatty acid composition of the feeds in terms of to keep the polyunsaturated fatty acids as low as possible. I know that can actually get into conflict with some other interests, like some nutritional interests, or even the cost of the materials for preparing, for designing the feeds. But from an oxidative point of view, it is to have polyunsaturated fatty acids is not convenient at all. Then we have supplementation with tocopherol acetate. This is very commonly used for both monogastric animals, broilers, pigs, and also ruminants. But at least I've been involved in many studies, and well, I think it's perfectly proven that supplementation with tocopherol acetate is a very good strategy for controlling lipid and protein oxidation during storage and processing. In particular, lipid oxidation, for one reason, is because, as you know, this tocopherol, this vitamin E, will be located, is specifically accumulated in the membranes of the muscle cells. And in this particular location, they are very effective antioxidants because in that particular location, we find phospholipids, which are from the membrane, B layer, that contain very high degree of polyunsaturated fatty acids. So this is actually where oxidative reactions are supposed to begin in muscle tissue. There are many studies proving these positive effects. And then if we have a higher level of antioxidant protection, we may need supplementation with some micronutrients, because I don't have time now. Basically, to mention the selenium, which is also proven to be effective against lipid and protein oxidation. Seated on that table, we have probably the most recognized expert in selenium. So if some questions are received, probably he should handle these questions. We know that organic selenium is more effective than inorganic selenium. In particular, I would like to mention a study carried out by members of Ariseo, actually the organizers of this Advancia Academy, because they used a hydroxyl analog of selenomethionine, and they observed how supplementation with this selenomethionine led to an increase of the accumulation of selenium in the muscle. There was also an increase in the activity of some antioxidant enzymes, endogenous antioxidant enzymes, in particular the glutathione peroxidase. And finally, that was also reflected at meat quality level, because this supplementation was able to reduce the levels of lipid oxidation measured by T-bars and also the discoloration of meats. Let me also mention very fast now this feeding on natural resources. That also has been proven in some particular animals to be effective to protect lipids and proteins against oxidation. These are Iberian pigs that we are raising in the part of Spain I'm coming from, in Extremadura. We are having these pigs extensively reared. They are fed with acorns and grass, and this has been proven to increase the level of monounsaturated fatty acids and tocopherols in the muscles and livers and adipose tissue of these animals, with positive consequences in terms of oxidative stability. And finally, we have supplementation with phytochemicals and phytogenics. Once again, Peter Sura is the person to ask whenever we have any questions regarding this possibility, because he made a very interesting review on this particular topic. And actually, in a way, maybe we can discuss that during the debate. But basically, these phytochemicals, these phenolic compounds, polyphenols, flavonoids, we have a large variety of different compounds which are naturally present in fruits and vegetables. They can actually be not only antioxidants as such, because of the chemical structure, as radical scavengers. They can actually be or act as modulators of the gene expression, which is something very interesting and can be used not only as antioxidants, as health and growth promoters, etc. But we need to study more about these phytochemicals and the possibilities that they have in animal nutrition and also in human nutrition, by the way. Once again, the theme of this session is missing in my conclusions. I don't know why. Actually, I wanted to emphasize this theme, but basically it's the relationship between animal nutrition and the impact on meat quality. So once again, this responsibility of the animal nutritionist on meat quality, because actually a lot of the quality of the meat is based on the quality of the feeds that we are giving to the animals, together with the genetic background, the feeds that we have mentioned, and also animal handling. And basically, we need to preserve meat quality, because basically, which is the ultimate purpose of animal production, to keep the business alive. So, and for keeping the business alive, we have to keep this cycle going on. So basically, we have to preserve meat quality, and we have to guarantee the satisfaction of the consumer. And that's all. Thank you very much for your attention. And sorry, because I spoke too much.